All right, this is a very tough question. If you're behind on time, this is probably something that you want to avoid attempting. It's also something that if you look at it and you're not even sure how to approach it, you're better off just saving the time on a practice test, moving forward, trying to make sure that you finish on time, you save time for questions you can actually answer. But the most important thing here is that X is positive, because X being positive allows me to do some algebra that I wouldn't otherwise be able to do. If we look at statement 1, it says that x squared is less than 2x is less than 1 over x. And it's our job to figure out if this is possible. Well, if I know that, taking this piece by piece, if x squared is less than 2x, because x is positive, I can divide both sides by x and end up with one formula. Whereas if I didn't know if x was positive or negative, I'd have to be worried about possibly flip-flopping that inequality sign. So I know that x is less than 2 based on this. I don't have to worry about flipping the sign. Now, how about evaluating the second part of the statement? How would this be true? I want to make sure that they're not contradictory to each other, that it's actually possible for all of this to happen simultaneously. So this reorganized would be x squared is less than 2x squared is less than 1, x squared is less than 1/2. And basically, in order for x squared to be less than 1/2, if you imagine, I'm just going to take a random fraction, not so random. I'm thinking about this in advance, actually. If I square 2/3, I end up with 4/9, which is smaller than 2/3 because 2/3 is actually equal to 6/9. Fractions less than 1, between 0 and 1, always get smaller when you square them. And this is pretty close to 1/2 if you look at it, because 4.5 over 9 would be 1/2. So essentially, I'm saying the x would be equal to the square root of 1/2, which means x is about equal to 2/3, or less than 2/3 rather, because it has to be less than 1/2. Because when I square 2/3, I get pretty close to 1/2. So the square root of 1/2 is about 2/3. And that can be pretty confusing if you're not used to working with fractions and exponents. But if you square it like we did here, you'll see that it does come out pretty close to 1/2. And you could do this in Excel, take the square root of 1/2, just say 1.5 up to the 0.5 power, and you'll come up with an answer. And it'll be pretty close to 0.667, though not exactly there. So we know that in situations where x is less than 2/3, the back half works. When x is less than 2, which obviously x is less than 2 if it's less than 2/3, the front half will work. So in any situation where x is less than 2/3, roughly, we should get this situation in terms of ordering. So if I plug in 1/2 for x, I would get 2, 1, and 1/4, which does follow the ordering where 1 over x is the largest, and then 2x is the second largest, and then x squared is the smallest based on statement 1. If I take statement 2, so statement 1 is possible. If I take statement 2 and evaluate it, x squared is less than 1 over x is less than 2x. Looking at this first part, x squared is less than 1 over x when 1 is greater than x cubed, which means basically x is less than 1. Because when x cubed equals 1, x would be equal to 1. Anything between 0 and 1, when you cube it, is going to get smaller, and so it'll become less than 1. Anything greater than 1, when you cube it, will get larger, and so it'll be greater than 1. So this is essentially telling me that x is less than 1. Now, the back half here is basically the same as what we were looking at before, where we found out that x was less than 2/3 on this side. But instead, on this side, it's reordered. So we have 1 over x is less than 2x, which means 1 is less than 2x squared, which means 1/2 is less than x squared, which means 2/3 is less than x. So in situations where x is less than 1, but greater than 2/3, roughly, because we know this is an estimate, we should have a situation that works for the second ordering. So let's try it out. So something between 2/3 and 1, let's call it like 9/10. That's like a pretty big fraction that's not quite 1. If x is 9/10, then 1 over x is 10 over 9, and 2x is 18/10, and x squared is 81 over 100, which is about equal to 8/10. Okay, so if we look at this, the largest number is 2x, which is what we see in the second statement. The second largest number is 10/9, which is greater than 1, which is the 1 over x. And the smallest number is x squared, which is 8/10, which is smaller than 1. So the second statement is possible based on this ordering. The third statement, if we look at that, is not going to be possible. And the reason is, if we take it and break it down, 2x is less than x squared is less than 1 over x. Take the first part. So if I take 2x is less than x squared, that means 2 is less than x cubed, which means x is greater than the cube root of 2. And the cube root of 2 is something greater than 1 but less than 2, because when I cube it, so it's like 1.2 or 1.1 or something like that, when I cube it, it has to get bigger and become 2. And if it was less than 1, it would get smaller when we cubed it. So I know it's a number slightly greater than 1. So we'll just hold that for now. What does this second part say? X squared is less than 1 over x, meaning 1 is greater than x cubed. Well, we know this means that 1 is greater than x because of the conversation we had earlier. There's no way that x is greater than a number greater than 1 and also less than 1 at the same time. So this is inconsistent information. This is impossible. And our answer is answer choice D, which is 1 and 2 only.